I'd like to do today is go through some textbook examples. You guys have been working on that booklet of stuff. To be perfectly honest, they're kind of easy.
Some of them are, yeah.
Yeah, some of them are. So we're going to be moving into some more challenging ones here. Let's start with, these are from page 56. If you want to follow along in the textbook, you can. I've given you the questions written out here, and that way you've got them. If you go on to university and you need some physics help or whatever, then you can think back to these, and hopefully you'll still have them. So there's the formulas there. Let's begin. Kitty O'Neill, a female dragster, reached a speed of 628 kilometers per hour from rest in 3.72 seconds. How far did she travel in that time? So your first step is to take that 628, and hopefully you remember that divide by 3.6 gives you meters per second. So that's 174.4 meters per second. And you are asked to find the distance. So before we can do anything, we're going to have to find the acceleration, right? Let's just write it this way. Let's write VF equals VI plus AT. The final velocity is my 174.4. My initial velocity is 0. My acceleration in the time, 3.72. And I'm hoping that most of you can easily see that the acceleration is 46.9 meters per second squared. Relatively straightforward. Now there's a couple ways to do it. Now I would suggest VF squared equals VI squared plus 2AD. Final velocity is that 174 value. It's squared. Initial velocity is 0. Acceleration of 46.9. Solve for D. So your D value is going to be 174.4 squared divided by. Thanks for sharing right now. Can we just...
Okay.
300...
See that one episode?
I own the entire 7.
I have to say no to the other D4.
You can do that too, Mike, yeah. 324.3. Relatively straightforward, that's just kind of a warm-up one, right? Moving on to example 8. Now, example 8 is really, it's really no different. It's exactly the same. It's different numbers. The only thing different car. The only thing different is that here the initial velocity was 0. Here the initial velocity was 20. So it's really exactly the same, right? So I would suggest VI is equal to 20 divided by 3.6, or 5.6. VF is equal to 230 divided by 3.6, or 63.9. Same ideas, right? Okay, so there's the acceleration. You guys should be able to solve here for VF. These are pretty straightforward. Right? I'll just give you the answer. Pretty straightforward, not too much of a problem. It's really a little bit later that we really need to start concentrating here. Well, like, I mean, they're different, right? They're something new, right? These are just kind of warm-up kind of things, right? Okay, acceleration of an airbag, if it deploys in 30 milliseconds and moves out a distance of 40 centimeters. Here, the key idea is that you've got to do some conversions. So 30 milliseconds is 31 thousandths of a second, right? Or 0.03 seconds. Yep, that's fine too. 40 centimeters is, of course, 0.4 meters. Once you've done that, it's a simple matter of d equals vit plus 1/2 at squared. 0.4, initial velocity is 0, which is nice. We don't have, oh yeah, we're finding the acceleration, and the time squared is 0.03 squared. So your A value is going to be, it's going to be 0.4 divided by 1/2, right? And also divided by 0.3 squared, 0.03 squared. $880.9. Let's write that over. Sure. Yeah.
That's a lot.
How much did you get?
888.
888?
Yeah.
Did you do the whole thing in one sort of?
And that's the answer in your video.
Oh yeah? Oh, it is 888. Sorry, I just can't read my own writing.
It's cool to have it 7 meters per millisecond, right?
I would recommend not.
They never like that.
It's not technically correct, but yeah.
Never like that.
All right, example 11. This is the one where we really got to sort of pay close attention here. It's getting a little bit more challenging. Jane Bond, that's James's daughter, I think, right? Runs down the sidewalk, accelerating uniformly at a rate of 0.2 meters per second squared from her initial velocity of 3 meters per second. How long will it take Jane to travel a distance of 12 meters? So, we know the acceleration of 0.2. We know the initial velocity of 3. We do not know the final. We're solving for time. We know the distance is 12 meters. So which one has D, VI, A, and T in it? Well, it's VIT plus 1/2 AT squared, right? Distance is 12. Initial velocity of 3, so 3t plus 1/2 of the acceleration of 0.2t squared. And I hope that you've just realized that this is going to be ugly. It will be. 1/2 of 0.2 is 0.1 t squared plus 3t minus 12. And what does that mean, Tony? It's a quadratic, exactly. Which means to solve it, we're going to have to use the quadratic formula. We're going to have to use the quadratic formula, which is x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Minus b is going to be minus 3 plus or minus square root. B squared is 3 squared minus 4 times a, in this case, is 0.1. The c value is minus 12 all over 2a, 2 times 0.1. So guys, when do you use the quadratic formula? When you've got a quadratic equation, t squared and a t, right? Now, is there another way to solve this? A quadratic like that? If you want to factor it, anybody want to factor that? How would you do that? How would you factor it?
You can't go to DCF. You'd have to divide by 0.1.
It's going to be, no, it's going to be a binomial. It's going to be t minus something and t plus something. Right? I would recommend, you're going to have to, just to make it easier, multiply everything by 10, so you get t squared here. So you'd have t squared plus 30t minus 120, and you'd need factors of 120 that add or subtract to 30.
I hate factoring, so let's not.
Okay, let's not. Okay. So 3 squared is 9. Whoa.
That's a negative
9.
minus.
Well, it's yeah, it's b squared. 3 squared, right? 9.
No, sorry, with the next.
Oh, okay. So it's minus 4 times 0.1 is 0.4, but I've got a negative here, right? That's a minus. So it's -4, -12. So it is going to be positive. So it's going to be plus or minus. I get plus or minus. Oh, I did it like this. Yeah, I did plus or minus 3.7. Is that okay? That's just the quadratic formula, plus or minus. Yeah.
Oh, I thought you were talking about inside.
No. Okay, so now I'm going to get two answers here. I'm going to get -3, minus 3.7, so you're going to have minus 6.7 over 2, or you're going to have -3 plus 3.7, which is 0.7 over 0.2. This one here is going to give you a negative. Negative 33.5. This one's going to give you a positive of 3.5 seconds. Which one is the true answer? Can there be negative time here? No, there isn't. What you're getting here is, because you've got, this is a negative, no, positive. Because you've got a graph that looks kind of like this, right? You're solving for that one and that one, but because time doesn't exist in the negative sense, then that part of the graph really isn't there, which is why we picked positive time.
So if
This value really makes no sense, right? It makes
so if you
it,
did get a value of a negative time, it's just either just put it positive or you
no, it doesn't make sense in this situation. Well, actually, in this particular situation, what it means is that she is starting at 3. If you go sort of back in time, if you went back in time at an acceleration of 0.2, right, she would actually be traveling a distance of, I think it would be -12, right? I'm not really sure what that -33.5 means in that case. I know what it means in the next one. The next one is where it really starts to get tricky. Okay, so pay close attention here. Fred and Barney from the Flintstones are at opposite ends of a 1 kilometer long drag strip in their matching race cars. Fred accelerates from rest toward Barney at a constant 2. Barney travels toward Fred at a constant 10. How much time elapses until they collide? All right, pay attention, gentlemen. This distance here is 1 kilometer, 1,000 meters. They crash at some point. They collide, right? When they collide, what is the same? Not necessarily, because Fred's accelerating, whereas Barney's traveling at a constant speed. What's the same is their position, right? They're in the same place at the same time. So what I'm going to do is I'm going to let Fred be position 0, yeah, and Barney's going to be, I'm going to assign him a position of plus 1,000. Fred is going to be my origin, Barney's going to be my plus 1,000 position. Alright, so what we have to do is we have to figure out when their positions are the same. Okay? So, Fred, we're going to say, is moving in a positive direction. Barney's going to be moving in a negative direction. Okay. Now, Fred's position. Fred's position is equal to his displacement. He starts right at 0, right? So Fred's position is equal to his displacement. Displacement of Fred, because he is accelerating, is going to be VIT plus 1/2 AT squared. Fortunately, his initial velocity is 0. So 0t is 0 plus 1/2 his acceleration of 2t squared, which when you boil it all down, half of 2 is 1, is equal to t squared. Fred's position is equal to t squared. If after 3 seconds, he's going to be at 9 meters. Right? Barney's position is a little more challenging. DF, displacement Fred. Because Barney starts at 1,000, right? His position is equal to 1,000 minus his displacement. If his displacement is 100 meters to the left, he is at position what? If his displacement is 100 meters to the left, his position is 900. Right? He's at spot. Like if he goes 100 meters left, he's right here at position 900. Right? It's the positions that have to be the same, not the displacements. Does that make sense? Correct? Positions have to be the same, not the displacements. Listen. These are the hard ones. Gotta listen. Okay. So, fortunately, Barney's traveling at a constant speed. So what's the formula for displacement for constant speed? V times t. So his position is going to be, let me do it in blue. His position is going to be 1,000 minus his velocity, 10t. Okay? T is time. The question is, when do they collide? How much time elapses before they collide? How much time before one of them has to veer off to the side? Well, they collide. They collide when positions are the same. Oh, I should have wrote that down. Sorry. Good question, Mike. No, blue. Constant velocity times t, right? 1,000 minus 10t. The velocity is 10. Right? Okay, so they collide when their positions are the same. So we're going to set them to the same. Fred's position is df. Barney's position is, I guess this is dB. Actually, it's not dB. It's technically, sorry. I'm a little bit distracted. Fred's position, which we'll call position Fred, and Barney's position, which we will call PB lead. Right? So PF is equal to PB. PF, we worked out to his displacement, which was equal to t squared, and PB is 1,000 minus 10t. Again, we've got a quadratic formula. t squared plus 10t minus 1,000 is equal to 0. Is that factorable? Well, I mean it is, but is it going to be easy to factor? Can you come up with numbers that multiply together to give you 1,000 that add or subtract to give you 10? Like 502, 254. It's not going to be easy, is it? No. Let's go to quadratic formula. T is equal to minus b plus or minus square root b squared minus 4ac all over 2a. Minus b is minus 10 plus or minus square root b squared is 10 squared minus 4a is 1, c is minus 1,000 all over 2a. Am I going too fast? No? 2a, sorry, should be just 2, right? 2 times 1. Ah.
I would say,
11.
might as well just leave it as 2, we know. Negative 10. For B, why are you not rolling 8,000? It's 4,000.
B is the number in front of t.
10 squared plus 4,000.
Yeah.
A is the one.
So that's going to be, A is the number, right? 4,100 all over 2. So we're going to get, you actually get two values. You either get plus 27 or minus 37. You're going to get two values, right? You're going to have minus 10, subtract the square root of 4,100, which is going to give you a negative value all over 2. So clearly, minus 37 doesn't exist in Fred and Barney's universe. They collide after 27 seconds. We could also predict where they collide too, right? By plugging 27 into here. Squaring it would tell us Fred's position. Pardon me?
So they didn't ask that on the question.
No, they didn't. So we'll leave it.
729.
I'm going to go do my attendance. I want you to read the last one. Jack is running for the bus. And see what you think. All right, so in this particular example here, Jack is trying to catch the bus. Very similar to Fred and Barney, because when does he catch the bus? When their positions are the same. But in this particular situation, it's not Fred and Barney coming together. These two objects are both going in the same direction, but very same idea. Well, the bus is slow to accelerate, right? It's large. Yes. It's not Jack, it's...
That's slow to accelerate. Have you ever been on a bus?
Yes, I've been on a bus, man.
Wow. Do you honestly think you couldn't keep up, or you'd be able to keep up?
Are you telling me that if someone missed the bus, they wouldn't try to catch it, though? I'm not saying he catches it. He tries to catch it.
20 meters.
What?
That's not bad.
He sees it, he's got 20 meters to catch it, right?
20 meters. It's like this.
Maybe the length of the, well, no, a bit more. It's quite a bit, actually, 20 meters, right?
30 feet.
Yeah. Okay, so let's set Jack's position at 0. The bus's position is plus 20.
It's like 20 yards.
Okay?
Okay.
Jack's position Jack, is equal to his displacement,
Here's pretty much the
because he starts at 0. And he is running at a constant 6 meters per second. So that's going to be VT. His position is 6 times T. Right? The bus, position bus, is going to be displacement bus plus 20. Right? Whatever the displacement is, plus 20, because he's got a 20 meter head start. The bus is the one that's accelerating. So the D is going to be equal to VIT plus 1/2 AT squared, and then plus the 20.
How do you get 60 again?
Jack is running at 6 meters per second.
Oh, yeah.
Constant. Yes, it's not an average, it's a constant. Initial velocity of the bus is 0, which is nice. 1/2. The acceleration of the bus is 1. T squared plus 20. So I got 1/2 of 1. So it's just 0.5 T squared plus 20. When does Jack catch the bus? When the positions are the same, right? So position Jack is equal to position bus. 6T is equal to 0.5T plus 20. Quadratic formula, 0 equals 0.5T squared minus 6T plus 20. So I solve quadratic formula. T is equal to minus B. So that's going to be 6 plus or minus square root. Do I have to write minus 6 squared? Or can I just write 6 squared?
36.
Sure.
Don't have to minus 6 plus or minus.
No. Oh, it is minus. It's minus B. Minus 6.
It's 2 minus, which is.
Oh, right, it's minus 6.
Right? So this is going to be 36 minus 4 times A, 0.5 times 20.
So 2 times 20.
All over 2 times 0.5. Point, or 4 times 0.5 is 2 times 20 is 40. 36 minus 40 is? What does that mean? What does it mean when you've got negative here? It means it's unsolvable. Which means what?
He doesn't catch the bus.
Cannot catch the bus. Tough luck, Jack.
He's walking the worst route to catch the bus.
He cannot catch the bus. Okay? Alrighty. Time for me to be quiet. Here's a whole whack of textbook questions.
I don't. Text. I don't. Text.
Some of like the booklet pictures.
Here's a few to leave out. 50, 54, 55, 60, 67, 69.
That's a lot of questions, man.
Yeah. Don't do them all. Pick and choose.
Do page 64 and page 33?
Well,
37 questions.
yeah, don't do them all, man. Like, do 10.
I'm gonna go up.
Do 8. Do 8 or 10, right?
So why do you give us so many?
I'm just saying there's a whole bunch that you should be able to do. I'm not saying do them. I'm saying you should be able to do
My
them.
job in this class,